Hi everyone, and welcome to the first lesson of the Generative AI for Beginners course. This course is based on an open source curriculum with the same name available on GitHub. I'm Carlotta Castelluccio, AI Cloud Advocate at Microsoft, and in this video I'm going to introduce you to Generative AI and large language models. Large language models represent the pinnacle of AI technology, pushing the boundaries of what was once thought impossible. They've conquered numerous challenges that older language models struggled with, achieving human-level performance in various tasks. They have several capabilities and applications, but for this course we'll explore how large language models are revolutionizing education through a fictional startup that we'll be referring to as Our Startup. Our startup works in the education domain with the ambitious mission of improving accessibility in learning on a global scale, ensuring equitable access to education and providing personalized learning experiences to every learner according to their needs. In this course, we'll dive into how our startup harnesses the power of generative AI to unlock new possibilities in education. We'll also examine how they address the inevitable challenges tied to the social impact of this technology and its technology limitations. But let's start by defining some basic concepts we'll be using throughout the course. Despite the recent hype surrounding generative AI, this technology has been decades in the making, with its origins tracing back to the 1950s-1960s. The earliest AI prototypes consisted of typewritten chatbots relying on knowledge bases maintained by experts. These chatbots generated responses based on keywords found in user input, but it soon became clear that this approach had scalability limitations. A significant turning point arrived in the 1990s, when a statistical approach was applied to text analysis. This gave birth to machine learning algorithms which could learn patterns from data without explicit programming. These algorithms allowed machines to simulate human language understanding, paving the way for the AI we know today. In more recent times, advancements in hardware technology allowed for the development of advanced machine learning algorithms, particularly neural networks. These innovations significantly improved natural language processing, enabling machines to understand the context of words in sentences. This breakthrough technology powered the birth of virtual assistants in the early 21st century. And these virtual assistants excelled at interpreting human language, identifying needs, and taking actions to fulfill them, such as answering queries with predefined scripts or connecting to third-party services. And so, we arrived at generative AI, a subset of deep learning. After decades of AI research, a new model architecture known as the transformer emerged. Transformers could handle longer text sequences as input and were based on the attention mechanism, enabling them to focus on the most relevant information regardless of its order in the text. Today, most generative AI models, often referred to as large language models, are built upon the transformer architecture. These models, trained on vast amounts of data from sources like books, articles, and websites, possess a unique adaptability. They can tackle a wide range of tasks and generate grammatically correct text with a hint of creativity. But let's dive deeper into the mechanism of large language models and shed light on the inner workings of models like OpenAI GPT. One of the key concepts to grasp is tokenization. Large language models receive text as input and produce text as output. However, these models work much more efficiently with numbers than with raw text sequences. That's where the tokenizer comes into play. A token is essentially a chunk of text which can vary in length and typically consist of a sequence of characters. The tokenizer's primary job is to break down the input text into an array of these tokens. Once we have these tokens, they are further mapped to token indices. And these token indices are essentially integer encodings of the original text chunks, making it easier for the model to process and understand. Now, let's move to predicting output tokens. Given an input sequence of n tokens, with n varying from one model to another, the model is designed to predict the single tokens as output. But here's where it gets interesting. The predicted token is then incorporated into the input of the next iteration, creating an expanding window pattern. And this pattern allows the model to provide more coherent and contextually relevant responses, often extending to one or multiple sentences. Finally, let's delve into the selection process. The model chooses the output token based on its probability of occurring after the current text sequence. This probability distribution is calculated using the model's training data. However, here's the twist. The model doesn't always choose the token with the highest probability from the distribution. To simulate the process of creative thinking, a degree of randomness is introduced into the selection process. And this means that the model doesn't produce the exact same output for the same input every time. And that's the element that allows generative AI to generate text that feels creative and engaging. We say that the main capability of a large language model is generating a text from scratch, starting from a textual input written in natural language. But what kind of textual input and output? First of all, let me say that the input of a large language model is known as prompt, while the output is known as completion, term that refers to the model mechanism of generating the next token to complete the current input. Let's do some examples of prompts and completions by using the OpenAI ChatGPT playground. A prompt may include an instruction specifying the type of output we expect from the model, such as a request to write an assignment for high school students, including 4 open-ended questions about Louis XIV and his court. A prompt might also include a question asked in the form of a conversation with an agent, like who is Louis XIV and why he is an important historical character. Another example of prompt is a chunk of text to complete, which implicitly is an ask for writing assistance. The examples I just did are quite simple and don't want to be an exhaustive demonstration of large language models' capabilities. They just want to show the potential of using generative AI, in particular but not limited to the educational context. That's all for this lesson. In the following lesson, we're going to explore different types of generative AI models, and we're going to cover how to test, iterate to improve performance, and compare different models to find the most suitable for a specific use case.